What's up, guys and girls? Welcome to chemistry once again. We have another flip session today, and we're at the point in class where we've learned beginning Stoic types of problems, and hopefully you're getting to the point where you're comfortable going between moles, grams, and molecules. So today's flip video is going to be on intermediate Stoic practice. So let's take a look at the first problem today. We're given our equation, which is unbalanced, and the question asks, how many water molecules are formed, that's our product, are formed from 10.5 moles of hydrochloric acid, magnesium hydroxide, MgOH2, is in excess. Okay? So as always, you want to pause the video, do your best, and we're going to get to the answer in a couple of minutes. All right, let's see how you did. Okay, so the first thing I noticed when I look at this problem is they want to know how many water molecules. How many water molecules am I going to get as my product, as your product? Formed from 10.5 moles of hydrochloric acid. And I noticed one last statement here. Excess. We're never going to run out of magnesium hydroxide. So I'm not even going to worry about this. Okay? And I'm not going to worry about the magnesium chloride. I simply want to know how much water am I going to get from the amount of product that I start with. In this case, 10.5 moles of HCl. All right. So the solution, well, as always, you have to balance the chemical equation. All right. Here's my solution. Number one, let's get our molar ratios. Right. I put a 2 in front of hydrochloric acid. There's a 1 in front of MgOH2, a 2 in front of water, and 1 mole in front of magnesium chloride. But once again, I don't even need these two substances. Why? Because I'm focusing on my HCl and how much water that's going to be produced from. Okay. Once we balance the equation, we want to calculate the moles of our desired substance. In this case, water. Right? We want to know how much water are we going to produce from our amount of HCl. So here's what I did. I took my given, this was given in the problem, 10.5 moles of hydrochloric acid, and I multiplied this by the ratio between how much water do I get from the amount of hydrochloric acid that I'm providing. It's a 2-to-2 ratio, or I could also call this 1-to-1 if I reduce. I'm going to get the same answer. This is a 1-to-1 ratio. So 10.5 times 1 is 10.5 moles of water. Notice this is still a 1-to-1 ratio. Nothing's changed except my label. I've gone from reactant, and I've made that jump from reactant to product. Lastly, well, let's stop here for 1 second. If the question would have asked moles of water, how many moles of water would we have made, we would be done right now. This problem's finished. But they didn't do that. They want to know how many molecules of water is this. So our last step here is using the molar roadmap. It's Friday, I can't talk. Let's convert between moles of water and molecules. Okay? And the one thing that we do in class that we've understood at this point is we use Avogadro's number. Right? So 10.5 moles of water, every 1 mole of water has Avogadro's number of molecules. I multiply these two numbers and I get 6.32 times 10 to the 24th water molecules. That's our answer. Okay? That's how much water we're going to get. We're going to theoretically produce, right? If everything goes according to plan, that's what we're going to get. based on our 10.5 moles of hydrochloric acid. All right, let's do one last question, problem for today. Okay, problem number 2. How many grams of oxygen gas, O2, are needed to react with 25.8 moles of C4H10O? I give you the equation. As always, pause the video, and we're going to take a look at the answer in a few short minutes. Okay, let's see how you did here. All right. As always, you want to balance this equation. Okay. How many grams of O2, which is a reactant, are needed to react with 25.8 moles of our second reactant? They mention nothing about product here. They never mention CO2, nor do they mention water. So I'm not even looking at these two substances. We just want to know how much of our second reactant, O2, is needed to react with our first reactant. Right? So as always, let's balance. Let's take a look at this. If we balance the equation here, here's what we get. Okay. This was a tough one to balance. Right? 1 to 6 to 4 to 5 ratio. But once again, I don't worry about these products. Right? We're just comparing our two reactants. So after we balance, let's convert our given amount to moles of O2. And here's our given. Right? 25.8 moles of our first reactant times its molar ratio, 1 to 6. Right? In other words, we're trying to make the jump from this substance to oxygen. And the only way we can do that is our molar ratios. So I get 25.8 times 6. I get 155 moles of O2. But they don't want moles. They want grams. So let's use the molar mass of oxygen. So 155 moles of O2 from the previous step. I know that the molar mass, or MM of oxygen, is 32 grams times my number of moles. And I get 4,960 grams of O2. All right? So yeah, these problems, they get more complicated. You just really have to have a game plan. How are you going to attack this problem? I personally would draw everything out before I start getting into a calculation and then realizing, oh no, I did it wrong, I have to go back again. Make a game plan. What are you going from? Grams to moles, moles to grams? And then start filling in the numbers. All right. So hopefully this helps as always, these videos. Good luck, guys and girls. I'll see you in class, and just keep on plugging away at these problems.